All right, ready? Let's define volume. Here we go. The three-dimensional. See, we're going 3 dimensions now. We're ending the class in 3 dimensions. The three-dimensional space inside a solid. It is always measured in cubic units of some sort. Same thing. Now we're going to be calculating that, but it's the same concept. That's a good connection. I believe so. Is that Rios teaching or Lopez? Cool. That's exactly it. That's exactly what we're doing. The three-dimensional space inside a solid, it is always measured in cubic units of some sort. And it could be cubic inches. Look at it can be cubic centimeters, cubic yards, etc. Dot, dot, dot. Let's draw a cubic unit. One unit. So the length, width, and depth are all 1 unit long. That would be a cubic unit. So how many of those will fill up a cylinder? How many of those will fill up a prism? How many of those will fill up a pyramid? All the solids you can think of. That's what we're thinking of when we think of volume, filling up 3 dimensions. How many cubic inches would fill up this classroom, and so on and so on. Okay, that's volume. No. Cubic units. 3 dimensions. All right, so let's find the volume here. Okay, does everyone have their formula tables out? Get your formula table out. Let's find the volume. The volume formula, capital V. And what's the alternative formula they gave you instead of that? They give you an alternative formula, or is that it? Did they give you a capital B formula? No? No. Right. Use the one for the general prisms. Look at the general. So that's for all prisms, the one underneath it? Yeah. Let's use that one. So it says capital B times the height. Right. Remember what capital B means from warm-up? Again? Area of a base. Area of a base. But the base here is not a circle. The base here is actually a rectangle. Look at the base here. I'm highlighted in blue. Let's find the area of that base, and that's going to be the capital B. The height is going to be the distance between both bases. Look at this top rectangle and the bottom rectangle are your bases. You want to put that on your picture, on your notes. The height is always the distance from both bases. And be 5 in this case is your height. It's a very easy formula, volume. So the volume then, the area of the base is the bottom rectangle. How do you find the area of a rectangle? Length times width, and that's from the upper portion of your table. So the volume then is length times width times the height. See, instead of putting capital B, I just put the volume, the area formula for a rectangle right there. And that's the area of the base. So what you need to know right now for a solid for a prism, the bases are always two faces that are the same. They can be the top and bottom, they can be the front and back, or the side and side. Those would be your bases. And the height is the distance between both bases. In this case, 5. There we go. The volume then, sure, go ahead. Right, for our purposes, we'll just use a general prism formula. For any prism. You see how the rectangular prism, what is the rectangular prism's formula? The first one there? What does it say? V is equal to what? That's for the general prism, right? Yeah. But what about the rectangular prism? What's the volume for that one? Look at that's what we got here. You see how this is the same as that. So what I'm asking you guys to do is just use the general prism formula for our class. Don't worry about the rectangular prism. Just use a general prism to work for any prism, whether it's a triangle on top and bottom, whether it's a circle on top and bottom. Just use this formula. That's it. Right, because look at the area of the base is a rectangle, huh? Look at exactly. See this rectangle, that's the base, and so is the top one, that's the base. I just need to find the area of one of them. That goes right here, and that's length times width. In this case, 8 times 3. 8 times 3. The height, again, is the distance between both bases, which is 5, excuse me. Let's rock and roll. Volume then is exactly. So volume then is chickens, horses, or termites. What kind of centimeters? What are you just talking about? Cubic. Cubes. We're filling it up. Done. There's your volume. Yeah, 120. Looks like 12.0. I bet. 120. Questions? Hit it. Hit it. Yeah, all this is going to be on Google Classroom. Yes. Length times width. 8 times 3 is 24. 8. What does it look like? Yeah. Yeah, you need my copy. I think you're right. But let's go to example 2 first before I force someone. Any other questions? Find the volume of this puppy. Yeah, it's example 2, right? Yeah. Let's find the volume of this one.
So we'll be using the
General prism. So find volume. Now I know this is a prism because it has two faces that are the same, namely the triangles. Look at the triangle in the front and the triangle in the back are the bases in this case. Right. You always look for two faces that are exactly the same. Those end up being your bases. Two faces that are exactly the same end up being your bases. That's a key note right there. You got to pay attention to what I'm saying. The two faces are the two triangles that are the same. Those end up being the bases of this prism. And I'll give you a minute to copy this down. So, volume formula for a prism, whether it's a triangular prism or a rectangular prism, this is what we call this a triangular, because the bases are triangles. Example 1 was a rectangular prism. The volume formula is the same. Area of the base times the height. It's a very easy lesson, this last lesson of the quarter. It's just that formula. And that formula is going to work also for cylinders, which is our last shape right now on example 3. Hold up, careful though. Careful though. What kind of shape is the base? The bases are always the two. The bases are always the two faces that are the same. Right, they're triangles, huh? So those are your bases. This means it's capital B means the area of a base, which means in this case the area of one triangle. You guys follow me? So what is the area formula for a triangle? Nice, base times height. Times, look at this now. Not the height of the triangle, but the height now of the prism goes right here. So you have to distinguish between two heights. The height of the triangle, look at the height of the triangle, versus the height of the prism, which is the distance between both bases, the both triangles. This is your height of the prism right here. That's your height of the prism, so be careful.
How would that be your height?
Because the height of a prism is always the distance between both bases, by definition. The distance between both bases. Watch, any guess? On example 1, both bases were these two rectangles, right? And the height is the distance between them, which was 5. In this case, the two bases are your triangles. The distance between them is your height. Right, because that's the area of a triangle. Now, what I'm trying to labor right now and stress is do not confuse the height of the triangle with the height of the prism. You got two different heights going on. Beware. You'll see this on the final. But the cool thing is this will be recorded so you can come back and watch this if you're a little scared. Or what? What did you say? Is he old grudges? He doesn't hold grudges. No. Here we go. Ready? 1/2 base. Base of the triangle, 12. Height of the triangle, 5. Remember, height of any triangle or parallelogram or trapezoid is always the perpendicular distance from the base to the opposite vertex. We went over that 2 days ago. So this is your height right here. That's going to be 5 here. Then the height of the prism is going to be 4. The rest is just that's it. Here we go. 1/2 times 12 is 6 times 5 times 4. 30 times 4, 120. Hey, the same answer. Huh? It's trippy. 120. Beautiful. Cubic inches. Rolling. Okay. Talk to me. Could someone, hold up, Garcia, he's got 4 things. Can someone answer Robles' question? What does capital B stand for? Area of the base. No, the area of the base is the area of a triangle, which in this case, what's the area of a triangle formula? 1/2 base times height. It's on your table, your formula table. In other words, I'm not asking you to memorize anything here. It's all on your table. So the area of a triangle is this. This is the area of a triangle. 2-dimensional area. And then you're going to extend it. Like you did in the video, you're extending this triangle in the 3rd dimension, the distance of the height, which is why you multiply by 4. You're taking a triangle and then extending it 3 dimensions. Last example. Let's do a cylinder. I'm going to get kind of sentimental. This is our last example of the quarter. Where's the Kleenex? Where's the Kleenex? By the way, that's problem of the week. Worth 2 assignments if you can do this. I'll put it up right now. Hold up. 2 assignments, not 1. 2 assignments. Did you hear me? Did you hear me?
I need it.
You need to. Find the bond. It's number 3. Whatever you want. If you can get that, you can do it. You can get whatever you want. You want a credit set? Fine. Just get it. All right, let's go. It's going to be on YouTube forever. This is your YouTube video? I got a whole channel.
Whoa, how many subscribers do you have?
Billions, man. Worldwide.
How do you need it then?
Tell you what, let's just do example 3. Go and draw the cylinder. 4.5 radius, 4.5 height. Question, any guys? Go ahead. The square, yeah. Always do exponents first. So the area of the circle is pi r squared. That's the base. Would it be? Yeah, it would be 20.25. 20.5 or 20.25?
20.25.
There we go. So 3.14 times 20.25 times 4.5. Chickens, horses, or termites? Cubic feet. Cubic feet. I'm about to cry. We just reached the end of our quarter.
Yeah.
Yeah.